This is going to be the Algebra 2 sample video for Quadratics for 2018-2019. If your class is using non-calculator methods to factor, this won't be applicable, but for my class it will be. All right, factor completely. What I want to do is I want to go to menu, and I want to go to equa for this one. Polynomial, degree 2. Okay, the number in front of x squared is 16. The second number is the number in front of x, and I don't have one, so I put 0 and then negative 25. Okay, so my solution is 5/4, so that would be 4x minus 5. And then moving down here to this one would be negative 5/4, so that's going to be 4x plus 5. If you have issues with the fractions, my recommendation is pretend as if that part's not there. So I would change the sign to plus 5, and then the 4 is the only place it can go is there. Now what I have to check for is if I multiply those two things, I would get 16x squared that matches there, so I'm good. I don't have a GCF issue. Let's move on to this one right here. Okay, that'd be 2, negative 7, and 6. So I solved that, I got x equals 2. And x equals 3 halves. So that's going to be x minus 2 and 2x minus 3. Notice the signs are opposite. Signs are opposite. Okay? Now, x times that would be 2x squared, so that matches up with that. I'm good. Okay? Let's move on down. Okay, our change is going to come on this next problem. This one, what I'm going to do is I'm going to type in 1, 16, 64. So that means I've got that solution twice. So I'm going to write the factor of x plus 8 2 times. That's what the times 2 means. Times 2 is reference to change, that's the solution, change that around. And I'm going to check. X times x is x squared. That's the same as this. This problem, what I would like you to do is change that to 25x squared minus 49y squared. Okay, that's going to get us better prepared for our test. Now, if I've got both x squared and y squared, what I want to do is I basically want to take out the y squareds. Okay, so I want to have that. And so when I go into equa and type that in, it's 25, 0, negative 49. Okay, and what that gets me is 7/5. All right, and negative 7/5, so just changing the sign. So that's going to be 5x minus 7 and 5x plus 7. Now, since I have both x squared and y squared, I'm going to make sure I put a y in there to finish that off. All right, and once again, 5x times 5x gives me 25x squared, so I am good. Okay? All right, so this one, this is a special one where there's going to be 4. I'm going to fill this in. The big thing is make sure that this back end has these two terms. So what I do is I look down this row, and the only thing I see in common here is a. So a times this has got to give me 7a, which has to be 7. A times this has got to give me 3a with x, so that's going to be positive 3x. 7 times this has got to give me 21, which has to be 3. Okay, so my factors are 7 plus 3x, a plus 3. Okay, that's all. We'll have to do the box of the 4 ones. Okay, and once again, 7 times a, 7a. I'm good. Okay, this one I would type in as 3, 18, 24. Okay, so I got negative 2 and negative 4. So that's going to be x plus 2 and x plus 4 when I change the signs. Now watch, when I multiply those, I get x squared. And if I notice, I have 3x squared. So the only way to go from x squared to 3x squared is to have an additional multiplier of 3. So those are going to be my factors. Okay, now, for these next questions, okay, all right, what I want to do is I'm going to make sure I can see those directions in there. Yep, I want to write the factors and the solutions. Now, in order to do that, I need everything set equal to 0. So what I'm going to have to do is I'm going to have to move the 6 back over. So I got 0 equals 7x squared plus 19x minus 6. So if it's positive 6 on this side, when it moves, it's negative. Okay, so I'm going to go into equa, 7, 19, negative 6. Okay, so I got 7x minus 2, because that's what that would be, and this would be x plus 3. So I got, so my solutions are 2 7s and x equals -3. Now, as I write the factors, so those are my solutions, I want to write 7x minus 2 and x plus 3. And what I want to check for is this times this. Well, this times this is 7x squared, which matches up with this. So these are the solutions. These are the factors. Okay? For this one, I want to move the 10x back over. So I got 15x squared minus 10x. Okay? So when I go into equa there, what I want to do is I've got to be careful because that's going to be 15. That's going to be 15. This is going to be -10 because that is the number in front of x. -10 and 0. So solve. I got 2/3 and I've got 0. So that's going to be, I'm going to write x equals 2/3, x equals 0. All right, 2/3 would be 3x minus 2. This would just be x. If I multiply these two, I get 3x squared. And if I compare that, I got 15x squared, so I would need a 5 there. So those are my solutions, those are my factors. This one is already set up. So I got 3, I got 5, I've got -2. I've got 1/3 and -2 are my answers. That's going to be 3x minus 1, x plus 2. If I multiply those, that's going to be 3x squared. And that matches up with that. If you want to put n there, fine. I'm not overly particular. This 64 would have to move back, so that's d squared minus 64. Okay? So the way that would go in, I could just pretend like that d is an x. 1, 0, -64. And that's going to be d equals 8, d equals -8. And that's going to be factors of d minus 8, d plus 8. And if you look at d times d would be d squared, and that's what I have there. Okay? Solutions, factors. We have to write both because they both ask for that. Okay? Question number 11 says solve. Okay? Well, that's already in the position to be solved. And the way I would type that in is 2, 0, -48. Because there's no x term there. When I hit solve, okay, I got 2 and -square root of 2. So what you can do is do plus and minus 2 square root of 6. Because the only thing that changes is the plus and the minus in front. Okay, this one I have to graph in the calculator. I cannot use equa for that one. Okay, because it's got the parentheses. So what I want to do is I want to go to graph. Okay, parentheses x minus 5 squared minus 1 is 35. Draw. Okay, now if my window is in tight, because that's a 35, I got to assume I got to zoom out, execute. Zoom out, execute. Now I see the intersection. G-solve, intersect. One of the answers is -1, and if I hit over, the other answer is 11. Okay? This one is an equal problem. Three, 0, 147. Okay, I got two answers, 7i and -7i. Okay, and that's good enough for that. I don't have to factor those because it does not say factor. Okay, all right. Okay, this is the quadratic, as 0 is this, write the equation. So what I need to do first is create the factors. The factors there would be x plus 2 and x minus 5. In order to find the equation, I would make the box with them. So x times x would be x squared, x times 2 would be 2x, x times -5 would be -5x, 2 times -5 would be -10. Now the only things that are going to combine there are those two numbers of, so all this is multiplication, okay? So 2 minus 5, which is -3. So I got my equation of x squared minus 3x minus 10 equals 0, okay? Sketch a possible graph. So the idea is that if it crosses at -2 and it crosses at 1, 2, 3, 4, 5, I can just make a generic quadratic, okay? So that's how you would make the sketch, right over here, okay? Pretty simple, okay? All right, moving on. Okay, given the graph, write the equation. So what I would have to do is interpret that is x equals 2. That is 1, 2, 3, 4, 5. That's x equals negative 5. So then my factors for that is x minus 2 and x plus 5. Okay? And I'm just going to go ahead and make the box. I think this is the same problem, is it not? Okay? Yeah, it's actually, no, it's slightly different. Okay, so what I would do is I make the box. So x times x is x squared. Negative 2 times x is negative 2x. X times 5 is 5x. Negative 2 times 5 is negative 10. These are the diagonals here of negative 2 and 5, so it's slightly different. Okay, so that's 3, so that's going to be x squared plus 3x minus 10 equals 0. The big thing is you've got to go from solutions to factors to equation. Okay, and when you do that, you have to use the box. Okay, what are the zeros of the quadratic given above? That's sort of a trick question. These are the zeros. Zeros are the same things as solutions. Okay, let's go on to 17. Find the discriminant. Just like the other ones, I got to move that back. So that's going to be 3n squared minus 7n minus 5 equals 0. What I'm going to do is I'm going to store this as A, this is B, and this is C. Okay? So the way I store that is I go 3, arrow, alpha A, negative 7, arrow, alpha B, and negative 5, arrow, alpha C. Then I do alpha B squared minus 4 alpha A alpha C. Okay? And so I get 109. That is the discriminant. Okay? Match the discriminant with the types of roots. If you get a discriminant of 0, you have 1 real root. If you get a discriminant of negative, you have 2 imaginary roots. And if you get just a regular number, it's 2 real. So the way that works out is positive numbers, negative numbers, and 0. Okay, that's how they correspond to those. Okay? Now, as far as the graphs go, the way they work is imaginary. It will not cross the x-axis. 1 real root will touch the x-axis. 2 real roots will cross through 2 times. Okay, so this is tied to negative numbers, this is tied to 0, and this is tied to positive numbers. And that's how that correlation works. So sketch an example of a quadratic with each of these discriminants. So that's a positive number. So just like that one, I would have 2 real roots. That's a negative number, so that would not touch the x. Okay, and this is 0, it's going to touch in 1 spot. Okay, now I can go through the y, it's okay. But only can touch in 1 spot. Okay? Alright, if this is the quadratic, alright, the solution, find the other. The only thing that changes there is the sign in the middle. You change the middle sign. So change middle sign. Okay, so that goes from, I keep that negative 6 with a minus, so negative 6 minus 3i squared root 2, that'd be that one. And to be honest, it also would be that one. I guess that wasn't changed. All right. And then question number 20. It says set up the quadratic formula for the following. Do not simplify. All right. Now we got to move that negative 4 back over, which that makes that 9x squared plus 3x plus 4 equals 0. Okay. Now this is my A. This is my B. This is my C. In the quadratic formula, this is the 7. Okay. So what I would do is that's going to be negative b plus a minus, all right, 3 squared minus 4 times 9 times 4, because that's the c, all over 2 times 9. And that's adequate enough for the quadratic formula. Okay, same thing. This says solve. Anytime you have solve, you can go ahead and just type that into the calculator. Okay, if they want you to set up the quadratic formula, that's something different. Okay, so what I got, all right, is 3, negative 1, 8. So my answers are, if you look at this, the only thing that changes is that. So 1, x equals 1 plus or minus square root of 95I all over 6. Right? We're good there. Okay? Solve by the quadratic formula. Once again, we'll solve whichever is the easiest way. So I'll go 3, I'll go 5, I'll go -2. The only thing you have to worry about in my class is how to set up with the quadratic formula. So my answers there are 1/3 and -2. Okay? Alright? It says we can look at different solutions. Solved by the quadratic formula. Once again, I'm just going to go in here, type in 2, type in 11, type in 5. Okay, I got two answers, -1 and -1/2 and -5. Okay, so if you were to look at that on a graph, basically what would happen is -1 would be right here, -1, 2, 3, 4, 5 would be here, and this would be my quadratic. Okay? Explain why you might choose a certain method over another one. Okay, from our standpoint, we're going to choose the easiest method. We're going to use for all the square terms, we're going to use equa. And for the parentheses ones, we're just going to graph it. And that's why. Our calculator is better suited for that. Okay? So, in summary, the biggest thing is anytime they say solve, or zeros, or roots, or x-intercepts. Okay? If it's a regular squared problem, okay, what we want to do is we want to use equal. Okay? If it is a parenthesis problem, we're going to graph it and find the intersection. Okay? We have to understand that so anytime they say solve, doesn't matter the method. Okay, if they ask for factors, the big thing is going to here, we have to change the sign. Okay? Alright? And if you understand that, you should be fine. Just practice that a little bit.